I am very happy to have George van der Walt with us today. So George is the head of exploration services at the MSA Group. He has over 20 years of experience in mineral exploration with travels in South Africa, Namibia, Botswana, Nigeria, Sudan, Niger, Kazakhstan, and Saudi Arabia. So it is going to be brilliant hearing from him today about uranium exploration in the Tim Mersoï Basin in Niger. So it is going to be a lot of fun. Please use the chat and we'll open up the floor at the end for some discussion. And yeah, thank you so much, George, for joining us today. I really appreciate you being here.
Thanks, Jessica. Nice
So
to see everybody.
it is good, huh? They're all coming through now, so that's awesome. Before we do get stuck into your session, I was curious what got you into geology in the first place.
I guess I always had a kind of a natural sort of preference for the scientific side in school.
Yeah.
Did a bit of geography and, the standard science subjects with maths and everything else. And when I got to university, I kind of didn't really know what I wanted to do. But I applied for general survey degree and a plain, straightforward, vanilla kind of science degree at two different universities.
Oh, wow.
And so I took the second option, which was just a plain science degree at Stellenbosch in the Western Cape in South Africa. And geology, maths, chemistry, physics as the major subjects, or the main subjects, and then kind of just geology was the one. It was the most appealing,
Nice.
sounded the most exciting and interesting to go into. So
Yeah.
I just followed the path, basically.
Just
I
took
think
it
most people end up like that.
Yeah, exactly. You just see where it leads you. So
Yeah.
you have traveled so much with your career. I was curious, what have been some of the big highlights for you so far?
Oh, it's hard to say. I spent a lot of time in South Africa initially. Most of my work was South African based until fairly recently, actually. So a lot of the travels have really only happened in the last 4 to 5 years. And I started out in the Bushveld complex doing platinum PGs, and that was really a lot of fun, spending a little time in a small town, just kind of being knocking around as a geologist in town and having the adventures that go with that. And then sort of shifted on to more consulting work, doing general things from based out of Johannesburg, but that's when I got into uranium as well, into the secondary uranium deposits that I'm doing now. So one of the interesting things is where I started, and wasn't for very long, was right at the beginning when I actually went to the Witwatersrand gold mines. I went to Mponeng Shaft, which is the deepest gold mine in the world. Currently, it's below 4,000 meters.
Whoa.
So I went down to shaft bottom just to have a look around. But as exciting and interesting as that was, exploration kind of just seemed more appealing. So that's when I shot off very quickly to go in the other direction.
Yeah.
So I spent a couple of years when I started doing the uranium down in the Karoo in the Western Cape in South Africa. I kind of learned a lot about channelized sandstone deposits. And it was just kind of where I found myself for a while, 8 or 9 years or whatever. Before eventually that whole project kind of shut down. Uranium's gone through lots of cycles, and it's quite difficult to maintain projects when that's going on. And so then I found myself back in Johannesburg, and ended up doing some various odd jobs, but one of them was pegmatites in Nigeria. So I spent another couple of years doing that. So it's become quite diverse, from PGs to sedimentary uranium to pegmatite deposits and a little bit of rare earths and what such in between. So some of the highlights in travels, it's hard. It's been so much in the last 2 years. I've spent some time, fair amount of time in Kazakhstan, which is a very interesting place. Lots of fun. Did some trips to Niger, as you know now, which we'll be talking about, and Sudan, Northern Sudan, DRC, Congo, Saudi Arabia a fair bit as well. And I think, yeah, towards the end of last year, I went to Brazil also to have a look at a pegmatite project there.
Wow.
And yeah, I've been to the US as well, but minimal sort of from a work perspective. I'll be going over there again in the next few weeks to have a look at the other project of the company that I'll be talking about now.
That is so cool. You've done so much travel.
Yeah, it's hard to keep track of these days.
It's a nice problem.
Yeah.
That's awesome. I did ask if you had any cool pet rocks that you could bring along today. I was curious which ones you decided to bring.
Yeah, I lost some of my rocks along the way, moving around a lot. But so some of the pet rocks that I have now are just boring old kind of bits of spodumene from South Africa, and I think this one's from DRC. There's a bit of real biotite mass from a gold project in northern Sudan. So it's probably got a bit of gold in it somewhere. Got a little tray full of ore minerals, so a little cube of chromatite from the Bushveld complex. Let's see, a couple of other things here. Rooiberg's a tin deposit in South Africa, and there's a little ingot of tin from the project.
Oh,
And the ore, the cassiterite ore that goes with it. And I don't know what else. Ferrochrome and copper sort of concentrate in a little packet.
oh.
This all comes in I actually don't even know where I got this from. Kind of inherited from some of my previous co-worker bosses. So it was a little like gift pack full of rocks of various ore types.
That's awesome.
Yeah, but unfortunately, not a lot of the real stunner sort of shiny rocks that you commonly find in geologist bookshelves.
Yeah.
And like I say, some of them got missing along the way.
That's so good. Well, yeah, thank you so much again for joining us today. I really, really appreciate it. If you want to share your screen and we'll get stuck into the presentation.
So this is a project that I got involved in, say, 2 years ago, a little bit more maybe. And we haven't done a hell of a lot on site because of as you'll get to hear later, the challenges of working in Niger. There's a lot of what this is about really, because if you read the news, you'll know about the developments in the country. I'm really wearing two hats today, which is the MSA Group, my primary employer, and my client, which is Myriad Uranium. Myriad Uranium is a Canadian Stock Exchange listed company with projects in, let's go, sorry, next slide. Let me start off with the MSA, Independent Consulting Group. We've got our head office here in Johannesburg, and then we've got an office in the United Kingdom servicing the in the United Kingdom servicing the European region. Saudi Arabia is setting up now in Jeddah, most likely for the Middle East region. We've got an office in Astana in Kazakhstan for the Central Asian region. We have a partnership running in Turkey as well, Ankara, and we've done up project work in South and Southeast Asia, North and South America. So we're pretty much global reach at this point. So 9001 and 45001 accredited group as well. Myriad Uranium, as I've said, is Canadian Stock Exchange listed, also on the Frankfurt, and they have two main uranium projects at this stage. The one is Copper Mountain in Wyoming, which is their newest addition, and the other is Tim Mersoï in Niger. Now, it started off with Niger, but the focus has shifted over to Wyoming, and that's got to do with the political situation in Niger, which I'll get to a bit later. So the Tim Mersoï area is barren. It varies from just nothingness to areas with grass and trees, a couple of camels running around. So it's a barren and hard place, as you could imagine the Sahara to be. It's on the edge of that, what they call the Sahel region or belt across the North Africa region that separates the desert from the more tropical regions to the south. But this is pretty much Sahara Desert. There's also some, beauty out there. This is a courtyard from the guest house that I stayed in the town called Agadez, which is, about a couple of hours from the project sites themselves. So, it's interesting. There's still a lot of French influence around there, in spite of all what's been going on in the last few months since July last year. I'm not so sure it's the same now, really. And when you go around, things can go wrong. So we had a breakdown in the middle of nothing, and the message there is just to be prepared, of course. So you can see what happened. Part of this sort of steering column broke on this 4x4 that we were driving around in. The solution looked like for a while it was going to be just tying it up with some inner tubes from tires and things like that, until they eventually found a bolt which they just miraculously found, put in and somehow worked, and we were able to carry on with the journey. Then there's always time to stop off for a bit of tea. They make this very sweet green tea. If anybody's been to the region, North African region, they'll know it. It's very sweet. And then always take protection. It is a bit of a region that's afflicted by all kinds of activities, and one of them is the fear of terrorist groups. There were incidents in this region a couple of years ago where there were attacks on the Arriva mines in the Arlit district, and in Agadez themselves, the military was attacked. And the US since then set up a drone base just outside Agadez to monitor the region. But yeah, you can never be too certain. I got the impression when I was there that the protection that was given to me was really just to provide some jobs for a few guys, and there was money has to be paid to provide this security. But he's pretty mean looking. He's got a big gun, so that helped. You do feel safer, because you never know what can go wrong. So this is getting into the meat of it. This was a prediction that was made by Standard Uranium back in 2021, September. The uranium market at a tipping point, and the clean energy transition is resulting in a supply shortfall that could tip the balance towards an era of rising uranium prices. And if anybody's followed uranium in the last few months to the last year or so, this has certainly been true. The whole kind of perception or sentiment around uranium has changed dramatically from a couple of years ago after Fukushima. You even had at the COP28, or I think it was COP28, a number of countries saying that they're going to be tripling their nuclear power outputs. And there's this whole pivot back towards uranium supply again. And you can see this nicely in the cycles of uranium. This is pre-2000. I'm not sure if you're seeing the pointer, but let me put the laser pointer on. Pre-2000 to 2003 almost, when we had the last boom, which peaked at around 2007 at something like $140 a pound of uranium. Then we had the global financial crisis, which really put a damper on things, but we started to see a recovery. And then, lo and behold, Fukushima happened, and all the way down we go. Several mines shutting down due to low prices and some COVID supply impacts that caused some blips. So we didn't really know where we were going to go with this, because the previous period prior to the 2007 boom was about 20 to 25 years of low uranium prices, like between the $10 and $20 range. But then something happened at the end of 2021, and that's around the time that Standard Uranium made their prediction here. So they did have a little bit of insight into it already because the prices had spiked at that point. But since then, it's just kind of motored straight up, and it's gone past 100. The numbers are not the same as on the scale there. So it peaked at just over 100 around January to February earlier this year. We've had a bit of a dip now towards the end of March, or the middle of March. But you know, this is another prediction by financial groups or whatever, saying that the dip is a new floor. So they don't expect it to charge back down to like $20 again anytime soon. They're saying that the fundamentals are there to keep it going. So we've got uranium prices sitting in the $90 to $100 range at the moment. Spot prices, long-term contract price from Cameco sitting at somewhere around $72, and $65 seems to be the magic number for a lot of projects to become interesting. It always seems to come up in financial assessments or feasibility studies that the price point of 65 is used to determine the feasibility of the project. And so, once you have long-term prices going over that breaking point, a lot of the projects suddenly become interesting again, and that's when you see the kind of activity that we're seeing now. A lot of new projects being brought either online or just kind of being, new exploration taking center stage. And we saw that quite a lot. I was in Vancouver in January, and Toronto for PDAC last month, and earlier this month. And the sentiment towards uranium on the investing side is strong. There's a lot of talk about uranium, where other metals like nickel and even lithium have all kind of taken a dive over the last year or so. So the big thing about uranium is this concept of recoverable conventional resources. The biggest deposits being in Australia, in fact. And but the important thing to note here is the point, so that the price point here under $130. There are other price points that lower down where some of these dots suddenly change in size and become smaller. But in terms of global recoverable resources below that price point, Australia is the biggest, followed by Kazakhstan, Canada, Russia, and Namibia. And Niger is following closely. Brazil's got a lot of big resources as well, but not as many of them are recoverable. South Africa, most of that comes from the Witwatersrand Basin as a byproduct of the gold. And then there's a few other countries around that kind of feature. The United States is interesting because it's only 1% of the global resources, but something like 95 or 90% of all of their uranium is imported from other countries. They still have huge reserves there, which is something that I think is becoming more prominent now in their politics, and there's a shift towards trying to promote domestic supply. So there's a lot of influencing factors here. Kazakhstan is such a big producer, obviously, because they've got in situ recovery methods that make them the #1 producer. So that's how when you compare the size of the dots of Australia and Kazakhstan, that's basically the answer. Kazakhstan is producing very cheaply, whereas Australia has got huge reserves, but they cannot produce it at the kind of price ranges that Kazakhstan is. And this is another view of that. This is the production. Kazakhstan, a huge chunk of that, 41%. Australia, only 13%. So the size of the dots there is flipped over completely. And it's clear because of the production, the recoverable resources ranges here. So between 80 and 130, there's the major sort of blue zones. But when you look at Kazakhstan in red, below 40. So they've got a real advantage in terms of producing at low cost. Even Brazil looks like it's quite strong in that respect, and it doesn't seem to feature a lot in when you talk about uranium. Every other country just about is looking at difficulties in terms of production costs. South Africa's got a little bit of advantage there because of the advantage around byproduct scenario. Canada, to some extent, because they have really high-grade deposits in Athabasca Basin. So there's a lot of different reasons why certain countries would, feature strongly in all of this. In terms of the Tim Mersoï Basin, that area has been dominated by Orano, which was previously Ariva. And the well-known deposits are Imararan and Arlit and these Sumer mines and Kominak. And these are some of the biggest uranium deposits in the world, albeit at lower grades than most of the areas around, you can't compare it really with Athabasca Basin, for example, where companies are reporting 10-20% uranium intervals. One of the groups when I was in Toronto now was releasing results where they had intersections up to 40% uranium, which is basically like having solid metal in your core. You can't just mine, you got to go in and mine that stuff with robots. You can't just go mine it by hand. So in the Tim Mersoï Basin, well over 1.5 billion pounds of resource represented. And some of the new upcomers in that area are GoviEx has been doing some exploration nearby for some time. But one of the really exciting ones at the moment is looking like Global Atomic, which has a DASA project, which is a reasonably sizable resource at a reasonable grade, and they actually start, still in the process of developing their mine, even with the political difficulties that have been going on there. So with the ramp up of production in this region, this could become the #2 producer in the world, just by sheer volume. So uranium, secondary uranium in particular, has got to do with, it's fairly simple. It's got to do with mobility of the uranium. So weathering from a source rock that contains uranium in the 4+ state produces the 6+ state of uranium, the hexavalent uranium. And this forms uranyl compounds, UO2 oxides. And these can travel by fluid flow down formations from the source rocks, which typically is sort of more igneous type rocks or basement rocks of some sorts, into confined sandstone channels or units, sedimentary units that are coming off these source rocks normally. The fluids flow in this oxidized state, and then when they hit a redox front, reducing area, which is either characterized by organics or some kind of carbon sort of boundary, you have precipitation back into the U4+ state. And this is a typical kind of roll front scenario where you have the oxidized area at the back. You can see typically in these areas hematite staining and limatite staining characterizing the oxidized state, and then that goes over to hematite and magnetite with an increase in pyrite content and carbon content on the reduced side. And often these are sort of confined between these claystone layers in the sandstone that's more permeable. This is just sort of another view to illustrate that in many cases, and this is the case in the Tim Mersoï Basin, the fault controls can also have an influence on where the uranium is precipitating. So this is quite typical of what you might see out in than the Powder River Basin in Wyoming, for instance, where they're doing in situ recoveries. They put down spot wells on this sort of area here, and then they just inject the fluids and extract the uranium without having to physically mine it. So the Tim Mersoï Basin then is located in one of these intracratonic basins in the West North Africa region. Several of them are located between these shield zones of the West African region and North Central African region. In particular, this Illumidan Basin has got, the Tim Mersoï Basin is a sub-basin of this area. And the myriad projects are located in this region here, which is between Agadez and Arlit in north central Niger. So in this setting, we have the air basement rocks. This is, you know, sort of Archean age basement, gneissic and granitic type rock formations that form these mountains to the east of the project areas. And then all of the sediments are deposited to the west, and they're gently dipping around 2 degrees towards the west-southwesterly direction. The prominent feature here is this fault, which is called the Arlit in Azua flexure fault. And what's immediately obvious when you look at the deposits that this is mostly what Orano is currently operating. All the major deposits are located along this fault trend in the north-south direction. Uranium is occurring in several different formations within the sequence. So the major ones being in these lower carboniferous formations. And then Imararan, which is that deposit, is sitting upwards in the Chrysaorine 2 formation. So it can occur at different levels. What you'll see in a moment is this simple classification of a red series and a lower gray series, which the gray series is the more reduced formations, and the red series is the more oxidized formations, as you can imagine. And there's also signs of carbon and organic matter that appear in this bit of coal deposits in some of these formations, and organic matter in others that controls precipitation of uranium. So considering that the fault control is so important here, we need to look at the tectonic evolution of the basin. The first is basement structures of Pan-African sort of age, and of which this north-south Arlit fault is one of them. Then we have a reactivation in the late Pan-African, which is these north 140 to 150 right lateral faults. Yeah, these sort of things. And then east-west compression, well, resulting from an east-west compression, as well as the 70 to 80 strike slip faults in Tinadra, so in the other direction as well. And then you have a reactivation of the Upper Cretaceous during the Upper Cretaceous of these north 30 reverse strike slip faults. Sorry, it's these ones, and then those 140, 150s on those directions, that kind of faulting there. And primarily most of these deposits or the mobility of the uranium fluids is in these river channel sandstones that would have trended in this west-southwesterly direction. So a fluvial type environment, similar to what you would see in the Karoo Basin in South Africa, channelized deposits, but forming these tabular sandstone deposits that can go on for miles. This is a very blurry image, unfortunately, because I had to lift it from one of the older Orano reports, but here you see the mechanism of it. The uranium fluids traveling down this Chrysaorine 2, for instance. This is at Imararan. Reaching this faulted boundary here, you can see the flexures there on the fault, and then precipitation occurring right near the base there. So it's had time to settle down and interact with oxidized areas, and you form these stacked multiple channels of uranium mineralization. There's another deposit on the western side called Imca, which is shallower, but it's smaller. This is sort of file images from, I don't know where I got them, either on the internet or in a report somewhere, but there you can see the clear distinction between the gray series and the red series on top. And this is in the Arlit open pit. And there's ore, which full of uraninite, cemented by uraninite, which is the main kind of uranium oxide mineral you would see in sedimentary deposits. I mentioned Dasa. They have an interesting deposit, and let me just step back. What's important to know is that most of these big deposits have been explored along the main Arlit Fault boundary, but what's become apparent is that there are major mineralization zones on other fault trends away from the main Arlit north-south fault. So Dasa is sitting there, for instance, and Elzilek is on this same fault trend. And Maduila of GoviEx is sitting on another fault trend. So this is a whole new kind of concept in the last sort of 10 to 15 years in this basin area, that the major obvious big deposits have been found along the main north-south trend, but there are other places to look, and Dasa is having a lot of success with that. So that is their kind of model. They've got a faulted graben structure where they've got mineralization sitting in these formations, and quite high grade. It's actually the highest grade deposit of uranium in Africa at this stage, on average. So the model for uranium mineralization here is something like this. You have the source in the uranium in the basin is volcanic material, possibly involvement of the bedrock coming from those air mountain massifs to the east. It's transported by chlorinated brines under the influence of the Permian Triassic evaporite levels. And then it's transferred through aquifers into the Arlit Fault and secondary faults, the North 30, 70, 140 kind of faults, along with deformation and abnormal heat flows during the opening of the Atlantic during the Cretaceous. You have a convection of these highly saline and hot fluids into the Arlit Fault. And then deposition is confined in the reduced areas and organic matter in the redox. So you've got each of these steps. You've got faulting, you've got transport and fluid flow, circulation in the fault zones here, and then deposition into the surrounding sediments as well. So what you can kind of see is that the red zone oxidized rocks, even though you have deposits up there for other reasons, here it's sometimes just a case of having your reduced rocks juxtaposed against your oxidized rocks. So the fluid flow from the oxidized rocks into the reduced rocks causes these precipitations here. And this is fairly recent kind of models that have been built by various authors now. So it's all got to do with redox reactions. The genetic model then is something like this in sedimentary uranium deposition. So you've got uranium coming down with the sediments and organic matter, but then you have to have remobilization followed by some diagenetic and hydrothermal activity, compartmentalized, but the fluids moving around and essentially precipitating against areas of differing oxidation states. And then the role of tectonics as well. You've got fault zones and carbonates developing along the fault crash areas and alteration halos and such. So that's partly the reason why the biggest deposits are kind of located along this Arlit Fault, but as I've mentioned, there's other options as well. So in terms of Myriad's project areas, there's 4 of them. We have about 1,600 square kilometers of ground there. Each of those is about 400 square kilometers in size. And the huge Irmararan deposit is sitting here. Just one of the projects, Ajabut, just to the north, and Afidi along to the south, and the Tagay projects to the south as well. These are all along that fault trend, which is one of the reasons why, you know, Myriad has been optimistic about potential success of finding another deposit here. You also have Dasa located there along the Azusa fault in that direction, and Azalik is to the west-southwest. They have a lot of interpretation of faulting from, you know, regional geophysics and such, which I'll get to in a moment. But what's also shown here is a lot of wide space drilling. I mean, I'm talking 800 to 1,600 meter space drilling across the entire area done by Arriva back in the sort of 2011s, 2010 sort of era. Several of them picking up some mineralization above the 100 ppm kind of level, but nothing major that stands out yet as a deposit strike. Well, and we'll get into that a bit in a moment. So this is regional geophysics mag on the left, and radiometric ternary on the right. What you can see on the right here is these sediments nicely reflected by the radiometric signals, and these massive displacements along these faults here, where Maduela, for instance, is located. Dasa is not as obvious with this imagery. It's not as good as the other imagery, but it starts to show some features that are very interesting. But the point that I want to get to on this is that the project areas are all located within these blocks here, and the faults that I've interpreted from all of these images are very much kind of sort of beyond deposit scale. They're kind of inaccurate. So when you want to go and plan a drill hole over here, for instance, looking at these huge distances, these are 20 kilometers across, becomes difficult to say where exactly one would want to put a borehole. So when you're getting to look at it at this scale, this is Afude, which is the middle deposit here. You have a lot of these lines and interpretations that came from somewhere, you know, got files full of fault boundaries and things interpreted from wherever they got interpreted from, but I don't know the accuracy of this. And again, when you look at the scale of the drilling spacing here, those are at least 800 meters apart along this direction, and more than 1.5 kilometers in that direction. You could fit an entire Imararan deposit in there. So if there are signs of mineralization around, but maybe you just haven't hit the main point of it yet, you know, there's something still to be said for further exploration. And the main problem that I was sitting with on where do we go with this, we've got this possible Azusa fault zone coming from Dasa and kind of cross-cutting Arlit. So really that should be a kind of an area of interest, but where exactly am I going to put my boreholes and not waste money doing the scattergun approach, which seems to be how it was run in the past, you know, just drilling grids across very wide areas. Junior companies don't have that kind of money, so one has to kind of try and think a bit smarter about these things. Fortunately, what we do have is some seismic profiles that were run by Arriva back in the 2010 era as well. So they ran 3 profiles along this area here. We'll just look at 2 of them, the profile 5 and 3. Profile 5 shows this interpretation of the Arlit Fault, which starts to look a little bit more almost like it's a reverse fault, first of all. So you've got this kind of changes in sedimentary levels here, and the major deposits are sitting probably in this kind of region or zone of that. I think, if I'm not mistaken, there's a borehole there, and this profile along the profile 3 goes north-south along here, but the nearest drilling on that side is somewhere on that side. So I think there's a whole area here that hasn't been drilled yet, and which is interesting for targeting in that sense. So that zone there would be, what I would call a target zone for in the strictest sense at this point. Then the north-south profile 3 shows very nicely the Azusa Fault, which is the one that goes all the way through to Dasa. And what I can point out, there is that's a borehole located at that position and a borehole located at that position. And again, that whole zone there hasn't been drilled yet. So there's certainly room for further work to be done. And the reason why Areva didn't get to that point at that stage was mainly because of what happened at the time, which was the attacks on the mining operations in Arlit and the military base in Agadez. And so they kind of really scaled back on this kind of activity. So again, we have the profile locations. We have a slightly improved sort of interpretation of where these faults would be on surface. I've drawn in additional lines of interpretation based on the seismic, intersecting at that point there for the Azusa Fault and the Arlit Fault intersecting the profile 5 over there. So it kind of narrows it down a little bit, but we still got hundreds of meters between these areas here. So I kind of started asking the question of how do we narrow it down a bit further? We can look at various geophysical methods, but seismics obviously is too expensive for this kind of early play. Radiometrics, not so much, because a lot of all of this ground at this particular deposit, for instance, is undercover. The radiometrics isn't going to help you a lot. What we can consider high resolution magnetics to help pinpoint structures at surface. Ground surveys, very large areas to cover, so it's not really that practical. Airborne still has a bit of a security concern. We were advised not to do fixed wing in that area just because of the possibility of something going wrong. So we did in the end settle for some drone surveys, tying kind of small high sensitivity mag equipment to drones and flying them over the area. We also considered electromagnetic methods and settled on trialing some NSAMT, natural source audio magnetotellurics, along the profiles 5 and 3 of the seismic to see how well they would compare. So that's the area that we were intending to do for drone coverage for magnetics, and then the AMT lines along the profiles, matching the seismic profiles. The magnetic, this is just total magnetic imagery eventually that came out of the mag surveys as the drone mag equipment. What's conspicuous here is the fact that we didn't cover all the area, and this is now where the challenges of working in the desert environment come in. There were a lot of difficulties in getting things going and with the personnel and the equipment, but eventually the weather conditions got the better of them. Higher gusting winds in the desert can cause chaos, and eventually the drone crashed. So they sat with a problem, which was later compounded by the political issues there. So we had people and equipment stuck in Niger for a little bit of time, which really caused a lot of problem. But fortunately, we did get some useful coverage out of it, which I did some basic interpretations on fine sort of level structures that were visible in the magnetic imagery coming through here. This is still from the seismic, the interpretation of the main fault and faults in the area, but these finer structures then also produce some interesting features that I think helps to narrow down the targeting a bit. So my thought pattern, targeting for me runs around looking at this area here. So from the major project area down to a couple of square kilometers here that we can investigate. This was an early interpretation by myself on just the imagery of the geophysics, but we did have some additional interpretation done by a proper geophysicist, because I'm not a geophysicist. And he was also able to pick up some other structures and features in the data that aren't readily visible. When you look at it like that, it's hard to say there's a lineament going through some of these places, but managed to pick up other interesting features that could well present targeting opportunities. Here are the finer structures that I was referring to that are visible in that previous image. So far more kind of detail put into this interpretation than what I had initially. There's another picture of the drone flying, and it carries this instrument called an aeromag, which is quite high sensitivity and a very high frequency sampling rate, I think something like 10,000 hertz. So compared to traditional fixed wing surveys that are flying at a higher altitude with lower frequencies, you can get much more sort of continuous reading coverage over the target area. Then on the AMT side, we had the crews putting out the AMT lines and doing their surveys. This measures the naturally occurring electric and magnetic field variations, usually formed by lightning around the world, with time to recover. And it's a resistivity method essentially. So it can pick up sulfides and geological structures, deformation forms and their spatial occurrence and depth variation. It's pretty rapid and cost effective compared to some of the other methods, especially seismic, of course, and less labor intensive than, say, doing full scale IP surveys, for instance. But we didn't really know if it would be that effective. This was more of a trial, really. So when we compare the Arlit Fault profile 5, what you can see is this sort of contrast of coloring along across the fault line, which correlates quite nicely with what the seismic is showing us. And further interpretation along these lines does kind of pick up other features that might be interesting, like that, for instance, and there and there. So I think there's some value in it. We did. I'm just going to zoom in on this area here, just to show it a little bit better. Quite clear that there are some layering effects here. The near surface environment is showing a layering effect followed by layers underneath here, and even on the eastern side, you do see the layering becoming apparent in the sediments. That was profile 5 east-west, and then profile 3, or the north-south AMT line. A similar kind of scenario. We do see a change here adjacent to the Agadez fault, which I'll zoom in on. And then numerous other little features that have been interpreted along the AMT profiles. So I think it can be a useful method. It is just a 2D profile. There might be other ways to do this where we could set it up, requiring more data, closer spaced lines, to get 3D profiles set up. But this is part of the longer term thinking. So back to the targeting scenario around there. Certainly, I think there's a case to be made for targeting this area with some drilling in between the holes that drilled previously and in areas where there are quite wide gaps. On the other area that we wanted to survey, but we didn't quite get around to, we were planning to do the same mag survey type along in this block here, which is north of Imararan, and at this sort of convergence of faults. You have the convergence of faults here where Imararan is, and a similar kind of feature up in the northern area. And Arriva actually had plans to drill this area, which they never got around to either. So we would have followed up with a similar kind of mag survey and interpretation of the faulting to kind of narrow down the targeting. But that's essentially where we would have been targeting primarily on this project area. Other interesting areas might have been further up north there, where virtually no drilling has been done. But this is what goes on in Africa a lot. Anybody who's watched the movie Captain Phillips with where the ship gets hijacked by the pirates, in the Somali pirates in the Red Sea, they'll know that reference. I am the captain now. So this occurred on 26th of July last year. The military decided to step in and lock up the president and take over the country. And they've since kicked out the French. French are no longer sort of based in Niger. I don't think anybody with a French passport is even allowed to enter the country at this stage. The Americans are still there. They've got the base, the drone base operating, but some of the most recent news, as in the last week or so, is that they're trying to get them kicked out as well. So there's a lot of question marks around where this is all going. There's question marks around Russian involvement, which is similar to what happened in the neighboring countries of Mali and Burkina Faso. So uncertainty generally. And what we do know is that, they're not against having other Western players there, in the exploration scene. They're not against Canadians and Australians and any of those. It's more anti-French sentiment than anything else. And the directors of Myriad have been asked by the military to come and sort of see their new minerals minister, and kind of, I think we'll be put under pressure at some point to do some more work there as part of the fulfilling the kind of obligations towards having the licenses. But of course, one has to check carefully. You just don't know with these kind of things. So that's why most of the focus has been shifted across to Wyoming at this stage. And that's a whole different sort of discussion that I may be able to present in a follow-up at a later stage, I guess. And I think that's the whole story for now.